We are looking at the Pythagorean theorem today. Here's a little math joke. Okay, it says, "Ha, you wouldn't know an isosceles if it bit you in the hypotenuse." Really, Frank, sometimes you're so obtuse. Okay, so he's an obtuse angle. Haha, very funny. And he says, "And you're always right, Vivian." She's a right angle. Okay, so a little math joke. The reason I did this is because when we're doing the Pythagorean theorem, it has to be a right triangle. Cannot be obtuse, cannot be acute. Okay, so Pythagorean theorem, it says, in any right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the legs. Okay, you may have heard before, a squared plus b squared equals c squared. Okay, that's what we're looking at. All right, the square of the length of the hypotenuse, so c is going to be our hypotenuse, is equal to the sum, so we're adding these two together, of the squares of the legs, and these two are your legs. So I've got a couple samples here. Your leg and your leg are always around your right angle. Your hypotenuse is always the farthest away. Okay, again, if they spin it on you and your right angle's up here, again, it's your leg and your leg. A and B can be interchanged, but C is your hypotenuse. It has to be that side opposite your right angle. Again, if they spin it again, look for that right angle. Those are your legs, and then your hypotenuse is the third. So we have leg squared plus leg squared equals hypotenuse squared, or like I said on the previous page, a squared plus b squared equals c squared. So here's an example. All right, we have 40 miles on one leg, 50 miles on the other leg, and we want to know the length of the hypotenuse. So what we'll do is we'll take our a squared plus b squared equals c squared. One of my legs is 40, one of my legs is 50, and I want to know what the length of c is. Okay, now this is all in your calculator. Okay, so if we can see on here, try and get it close enough. All right, so you want to do 40 squared plus 50 squared, and that gets us 4,100. So let me write that a different way. Hang on. Okay, let's just change this to 4,100. Okay? Now what I want to do is I want to know what c is. C squared is 4,100. So something times itself gets me 4,100. So to undo that, I have to do the square root. Okay? So I'm going to take the square root of 4,100. So you've got your, can we see it there? All right, so we got second square root, and then we'll put in our 4,100, and that's going to get us about 64.03. Okay, so in other words, 64.03 squared is going to be the same as 40 squared plus 50 squared. Obviously, we rounded, so it's not going to be perfect, but we're just trying to figure out about what that length is. Okay, here's another one. We got a leg that's 14 feet and 11 feet. So I go 14 squared plus 11 squared. If I sub in for my legs, okay, we want to know what c is again. So 14 squared plus 11 squared gets me 317. So then I square root both sides, and I get about 17.8. It was 804, so I'm going to round that to 17.8, and that would be feet. I forgot a label on that last one. Last one would be miles. Okay? All right, now the difference on this one is I give you a leg and I give you a hypotenuse. There's a couple ways to look at this. We still have our a squared plus b squared equals c squared. One of our legs is a, and we know our hypotenuse. Okay, well 7 squared is 49. 13 squared is 169. Now I have to solve for b, so I'm going to subtract 49. So b squared equals 120. Take the square root, and that would get us our b. It's 10.95-ish, about, inches. Okay, that's one way to do that. All right, I'm going to show you another way. Another way would be to reconfigure this equation. So instead of a squared plus b squared equals c squared, well, if I take this away, I could also have b squared equals c squared minus a squared. Okay, so you can take your hypotenuse minus one of the legs squared and gets the other leg squared. So we can go with that if we want. So we can say b squared equals c squared minus a squared, which is essentially what I just did. It's just in a different order. So b squared, so 13 squared, we can save a step here. 13 squared minus 7 squared would be 120. Take the square root of both sides. And then again, it's going to be about 10.95? Yeah, 9.5. And our label is inches. Okay, so basically, if I give you a leg and a leg, you're going to add the two. But if I give you a leg and a hypotenuse, you need to subtract. You need to take the leg squared away from the hypotenuse squared. Okay, we also have what's called inductive and deductive reasoning. Inductive reasoning is a method of reasoning in which a conjecture is made based on several observations. Conjecture, remember, is just like a prediction. After you've seen a couple things, you're just going to predict what you think is going to happen. Okay, that's your conjecture. Based on several observations. Versus deductive reasoning, that's going to use facts, definitions, accepted principles, and properties to prove general statements. Okay, a lot more solid foundation on that one. Okay, so here's a question. It says, do you think vertical angles are equal in measure? Explain your reasoning. Okay, so vertical angles, if you remember, are the two that are across from each other. So we want to know, are those two equal? If so, how can we say that they're equal? Well, one way would be to draw and measure several pairs of vertical angles. And then we would use a protractor, and we would actually measure them. So you take your protractor, which I can't find right now. Anyway, so you take your protractor, remember that's that D-shaped thing, all right, and you'd actually measure the angles. So let's say this one measured out to be 60 degrees, and this one measured out to be 60 degrees. And then I drew two more, and I said, all right, well, this one ended up being 88 degrees, and this one ended up being 88 degrees. This one ended up being 20, and this one was 20. So there's my conjecture. I'm going to say that in all vertical angles, they're always going to be congruent because I measured it. That would be inductive reasoning, okay? Because I went and I measured and I made a prediction on what I've seen. Okay, method two, this would be using deductive reasoning, okay? When you take geometry, you're gonna do what's called proofs. This is a proof. They'll give you a statement, for example, like angle A and angle B are vertical angles. So angle A and angle B are vertical angles. We wanna prove that they're equal, okay? So we'd first say, well, A and C are supplementary. If you remember supplementary, two angles that are next to each other, they add up to 180 degrees, okay? We could also say that B and C are supplementary because they're two angles that are next to each other, they add up to 180 degrees. So, if A and C are supplementary, then A plus C equals 180 by your definition of supplementary angles. Also, just like that for number two, B plus C would equal 180 degrees, definition of supplementary angles. Therefore, if they both equal 180 degrees, that means they both equal each other. So A plus C equals B plus C. Well, you can see that C is repeated in both, so I could take that off of both sides by subtraction, and then we would say that angle A equals angle B. That would be using deductive reasoning. We're taking definitions, rules, theorems, postulates, all those things. That's deductive reasoning. Okay, so here's another example. Determining the area of the classroom by measuring the test. If we're measuring, that's going to be inductive reasoning. This one, determining the length of the missing side of a right triangle by using the Pythagorean theorem. All right, we're using an actual rule, something that's been proven over time, and that's going to be deductive reasoning. And one more, determining how many people will be in your next math class by looking at the enrollment of this class. All right, we're making a prediction. We don't know for sure. That would be inductive reasoning.